Dear students, welcome to Skip Uni. Let's just dive right in, shall we? इस लेक्चर में हम C++ में Encapsulation, Data Hiding और Abstraction के बारे में सीखेंगे। मैं एक्सप्लेन करूंगा कि इन तीनों कॉन्सेप्ट्स में क्या डिफरेंस है और इन्हें रियल लाइफ एग्जांपल्स के साथ कैसे समझ सकते हैं। अगर आप OOP इन C++ या C++ प्रोग्रामिंग फॉर बिगिनर्स सीख रहे हैं, तो ये लेक्चर आपके इंटरव्यू प्रिपरेशन के लिए सबसे ज़्यादा ज़रूरी है।
Seriously, I cannot stress this enough. If you're gearing up for a competitive exam or walking into a technical job interview anytime soon, mastering these object-oriented programming concepts is absolutely non-negotiable. Like literally, no technical interview is complete without these topics. You can't just memorize textbook definitions here. You really need to understand how they actually function in the real world.
So here's our game plan for today. We're going to cover 3 core pillars: encapsulation, data hiding, and abstraction. And then we'll wrap it all up with an interview cheat sheet.
All right, let's kick things off with encapsulation, binding the data.
Okay, so what is it? Well, encapsulation is essentially the process of wrapping data, which, in programming we call variables, and methods, or functions, together into one single cohesive unit. And in object-oriented programming, we just call that single unit a class. The easiest way to picture this, just look at the word itself. It literally has the word capsule right in it. Think about a medicine capsule you take when you're feeling under the weather. Inside that one tiny little outer shell, you've got several different medicines and powders all gathered and bound tightly together, right? Well, that's exactly what we're doing in our code. We take our specific data, our specific methods, and we bind them tightly together inside a single capsule. That's our class. Let's bring this to life with something we all use, like the Zomato app. Think about it. The app holds a ton of specific data for a restaurant. You've got the menu items, the prices, the star ratings. That's our data. But it also has actions you can take, right? Like adding an item to your cart or placing an order. Those are our methods. In the back end, developers take all that restaurant data and those ordering methods and they wrap them up into one single class. The whole shebang, perfectly encapsulated.
Moving right along to number 2, data hiding, which is all about ensuring privacy. So you might be wondering, why do we even need data hiding in the first place? It really boils down to privacy and security. Think back to how we used to share files in the old days. You take a pen drive, plug it directly into your friend's laptop, and just copy and paste raw data. Super easy, right? But in the real world, massive tech companies absolutely cannot allow users to directly access and freely manipulate their back-end databases like it's some shared pen drive. I mean, it would completely ruin the platform in seconds.
Going back to our Zomato example, as a user, your view allows you to casually read the menu and place your orders. But the database view? That is strictly hidden from you. Why? Because think about it. If you had direct access, you could easily just go into the database, artificially bump up a restaurant's rating to 5 stars, or hey, lower the cost of a super expensive meal to 0. So the company completely restricts you to prevent exactly those kinds of unauthorized changes.
So, how do we technically pull this off? Well, developers start by using encapsulation. And then they apply access modifiers. If you've been coding in C++, you see these everywhere: private, protected, and public. Private means the data is totally restricted from the outside world. Public means anyone can see it. And protected restricts access to derived base classes. By setting sensitive data to private, boom, we hide it. Then we just provide users with very specific controlled public functions to safely interact with that data without them ever touching the raw database.
All right, let's hit our third pillar. Abstraction, hiding complex details.
If you take away anything today, remember this golden rule. It focuses on what an object does, not how it does it. This right here is the core of abstraction. It's all about showing the user only the essential features they need to get a task done, while completely hiding all those messy, complex background details that, honestly, they just don't need to worry about.
A perfect example is driving a car. When you hop in and start the engine, you know the essentials, right? You press the gas pedal to go, you hit the brakes to stop, you turn on the AC if you're sweating. But do you know the intricate internal mechanics of how the engine actually transfers power? Do you know exactly how the brake system's hydraulics operate? No way! And you don't need to. All those complex background details are beautifully abstracted away from you so you can just focus on driving.
If we connect abstraction back to our food delivery app, what you see on your screen is just a super clean, simple status update: orders being prepared or delivery arriving. But what's deliberately hidden from you? The absolute chaos of the kitchen. You're not seeing the chef frantically pouring oil and frying up your food. You're not seeing the complex GPS algorithms working in overdrive to assign the nearest delivery driver. All those complex internal processes are totally abstracted away. You just get the clean, simple notification that actually matters to you.
Okay, wrapping up with Section 4, the interview cheat sheet, acing your interview. If you're sitting in an interview and they ask you to explain the differences between these concepts, here is your high-value summary. Encapsulation? Its core purpose is binding data and methods together. Just think of the medicine capsule or packaging restaurant info in a single class. Data hiding? That's strictly about security and privacy, making sure users can't just hack the back end and change dish prices. And abstraction? That's all about hiding complexity. It gives the user a brilliantly simple interface, exactly like driving a car without needing to be a mechanic. When you put them together, these three pillars are what make any software system secure, functional, and actually user-friendly.
So, as we wrap up this explainer, I want to leave you with a bit of a provocative question to chew on. How are you using these OOP pillars in the apps you build every day? Seriously, I challenge you to look at your own code today and spot exactly where you're encapsulating, where you're hiding data, and where you're abstracting complexity. Because honestly, spotting these concepts in the wild, that's how you truly master them. Best of luck in your technical interviews. You've totally got this.